Okay, so let's go ahead and take a look at another example of some of the types of questions you'll answer on the homework. It says here, determine whether the graphs of the given equations are parallel, perpendicular, or neither, and explain. So remember what we learned. We learned that in parallel lines, what do we have is we have the same slope, same m, different y-intercept. And that in perpendicular lines, it doesn't really matter what the y-intercept is. What matters is that the slopes are opposite reciprocals of each other. The slopes are opposite reciprocals of each other. I hope you understand my writing. Let me go ahead and write that a little bit better. All right, so let's take a look at example number 13 here and see if we can think about what's going on. What is the slope of the first equation, y equals x plus 1? Well, that slope is 1. And the slope of the second equation, y equals negative x plus 2, well, that slope is negative 1. So obviously, these slopes are not the same, so therefore they couldn't be parallel, but are they opposite reciprocals? Well, they are opposite, correct? One of them is positive and the other one is negative. One of them is positive and the other one is negative. Okay, so they are opposite. Are they reciprocals? Well, let's think about this. The whole number 1 as a fraction is 1 over 1. So if I flip it, what do I get? 1 over 1. It's the same thing. And this is negative. So therefore, here in number 13, okay, the slopes are opposite reciprocals. So therefore, number 13, these lines are perpendicular to each other. I just wrote perp, so you get the idea. Okay? Let's take a look at number 14 now. Number 14, the slope. What is the slope for the first equation? The slope is 3/4. And what is the slope for the second equation? Well, take a look at that. The slope is also 3/4. So, do they have the same slope? Yes. Do they have different y-intercepts? Yes. Therefore, number 14 are two equations that represent parallel lines. Now let's take a look at number 16. Number 16 requires a little bit of work because none of these equations are in a... Actually, it doesn't require as much work. You would think here that we have to work on both of these equations to get them in slope-intercept form, but we don't really need to do that. All we need to do is find the slope of the second equation. I already know the slope of the first equation. It's 3. Let me erase that and make that a little bit better here. It's 3. Because remember, when we do point slope, it's y minus y1 equals m times x minus x1. So m is the number in front of this parentheses, which in this case is 3. I already know my slope is 3. So let me go ahead and work out the other one. Here, I'm going to work it out down here. Here's my example for number 16. 2x plus 6y equals 10. So I'm going to go ahead and drag that 2x over there to the other side. And this becomes 6y equals negative 2x plus 10. All right. And then I divide everything by 6. And I get y equals negative 1/3 x plus 5/3. And what we can see here is our slope for the second equation is negative 1/3. So is negative 1/3 the opposite reciprocal of positive 3? And yes, they are opposite reciprocals of each other. We got one slope is positive 3 and the other slope is negative 1/3. They are opposite reciprocals of each other, therefore these lines are perpendicular. All right? And then finally, we have the equations y equals -7 and x equals 2. Okay? Now this one could be a little difficult to figure out using looking for the slope. But if we remember, I'm just going to draw a quick little sketch of a coordinate plane here. It's not going to be perfect, but it's going to be enough. We talked about this in class. Okay? This is our y-axis, this is our x-axis, and we talked about an equation like y equals -7. We talked about that as meaning all points, no matter what value x has, the y has a value of -7. So if you envision this being -7 down here, this point down here, so, you know, all these points would represent the concept of y equals -7. Okay? Do my best to draw a little line going through that so you can get the idea. Okay? Then, so what does, and I did this in red, let me just put a red arrow pointing at it so that you can remember. And then let's do this one in blue. What does x equal 2 mean? X equals 2 means that no matter what the y values are, the x values are all 2. So if this is 2 right here, okay, then that means all of these points represent the line x equals 2. So if I draw a line through this here, again, I would always tell you to do this with a straight edge, but then I look here, these two lines are intersecting to form right angles. So therefore, the equations y equals -7 and x equals 2 are perpendicular to each other.